okay, you will learn about the timer, okay, which this timer here is used in order to create a delay or to generate a certain event. Okay, so every time kamu nak buat to create a delay, okay, you can use a timer function, okay, in your Mega32 untuk generate delays. Okay, so in this dalam modul 12 ni kita akan lihat pada dia punya pengenalan dahulu, and then after that we're looking at the programming by using timer 0, 1 and 2. Okay, for the timer timer ni boleh dibahagikan kepada tiga jenis lah. Okay, we have 3 timers available in Mega32, which is timer 0, and then timer 1 dengan timer 2. Okay, and then after that we looking at how to program timer 0, 1 and 2, and at the same time we will learn about the counter. Again, what this counter do. Okay, so let's look at the introduction part dahulu, and then after that we start with the programming. So dalam micro:bit, okay, so there is a one register. Okay, ada satu register yang kita gunakan in order to count. Okay, untuk kita count an event, to kira an event, or to generate a time delay. So this counter here we call it as a counter register. Okay, so this counter register is actually the main important in the timer programming, in which this counter register is used to count an event or to generate a delay. Okay, so untuk timer dia ada dua fungsi. Okay, satu adalah untuk count delay, to generate delay. And fungsi kedua ialah to count event. Okay. So this is the function of the timer. Okay, so let's look at here to count an event. Okay, kita tengok fungsi yang pertama. What you need to do is you need to connect the external event source to the clock pin of the register. Maksudnya kat sini kamu kena sambungkan kamu punya clock source, okay, ataupun kamu punya external event clock, event source. Okay, so this one here, external event source ni selalunya kita gunakan switch lah. Okay, so we put our switch, okay, to the clock pin of the register. So the clock source is actually our switches. Okay, so what happen here is apa yang berlaku when an event occurs externally. Okay, every time you press a switch, the content of the counter is incremented. Maksudnya setiap kali kamu press the switch, so counter register ni akan increase, okay, by 1. Okay, kamu press, dia increase. Kamu press lagi, dia akan increase automatically depending on how many you press the switch lah. Okay, while to generate a time delay, okay, the second function here to generate a time delay, what you need to do here is you need to sambungkan the oscillator to the clock pin of your counter. Okay, so the clock source here datangnya daripada oscillator ataupun daripada Xtel. Okay, so this oscillator Xtel is actually your CPU punya speed lah. Kalau kamu masukkan dia punya input to your counter register, okay, that from the oscillator means that you're going to generate the time delay. Okay, so this whenever the oscillator ticks, okay, every time the oscillator ticks, the content of the counter is incremented. Okay, so selalunya kalau clock source, dia punya input something like this lah. Okay, so this is your clock input. So contohlah kalau we use the every rising edge, so setiap kali every rising edge saja, so what happen, counter register, okay, so counter register, dia punya content akan increment by 1. Okay, contoh yang ni 1, 2, 3, 4 dan seterusnya. Okay, so this is the general view of the counters and timer in microcontroller. Okay, so this is the counter register. Kamu ada counter register. And then yang ni lah dia punya input. Okay, so this input here can be from sama ada daripada oscillator, okay, which is this is your CPU punya speed, ataupun internal clock source, ataupun external source. Okay, external source ni selalu kita guna switches lah. Okay, to count an event. Okay, so what happen here is, contohlah kalau kamu punya ni, okay, kamu sambungkan CPU speed kepada counter register. So what happen here, you going to generate the time delay. Okay, kalau kamu sambungkan switch kepada counter register, so what happen here, you going to count an event. Okay, so counter register ni dia punya content, okay, kandungan of this counter register will incremented by 1 every time, okay, setiap kali oscillator ataupun your switches, okay, is produce the ni lah dia punya clock path. Okay, so the content of the counter register represent how many ticks have occurs from the time we have cleared the counter. Okay, so this is the introduction on the timer. Okay, so let's look how to, okay, sekarang ni kita tahu timer boleh dibahagi ke, boleh kita buat dua function, satu is to generate a delay and satu lagi to count a certain event. So now you're going to focus on the how to use the timer to generate a delay. Okay, so if you're using a timer to generate a delay, there are two methods here that you can use in order to generate a delay. Okay, so timer untuk generating a delay ada dua method. Satu kita panggil dia sebagai CTC mode ataupun compare mesh, and the second one here we call it as a overflow method. Okay, so let's look at one by one. Okay, let's look at the first method here. Okay, so what this first method do? What is the CTC mode do? Okay, first kamu need to clear the counter at the start time and wait until the counter reach a certain number. Okay, so CTC mode ni actually is a compare mesh lah. Okay, dia punya apa dia analogi dia saya boleh buat ialah, okay, you have a glass of a water bottle ataupun kamu ada botol air. Okay, let's this botol air, dia punya size botol air ni adalah 1 liter. Okay, 1000 ml. Okay, so botol air ni, okay, the maximum kat sini 1000 lah. Okay, so this is a 1000 ml. And then, so kat sini dia akan ada scale. Okay, so this is a 100 ml, 200, 300, sampailah 1000. Okay, so sekarang ni, okay, kamu nak generate a delay. Okay, kamu nak generate a certain time lah. Okay, delay time. Okay, so let's say lah, kita tuangkan air ke dalam botol ini. Okay, so you put a water inside of the bottle, and then the water level dia kat sini akan increase. Okay, 100 ml per second. Okay, so bila kamu letak je, masukkan air, every time it increase 100 ml, dia akan generate 1 second delay. Okay, and then you put another one, kamu letak lagi air, sampailah dia 200, so now you already generate 2 seconds delay. Okay, so now we're going to see the CTC mode lah, macam mana CTC mode ni berfungsi. Okay, untuk CTC mode, apa yang kamu kena buat ialah, let's say you are going to generate a 5 second delay. So what you going to do? Apa yang kita kena buat? Okay, we need to set a threshold. Okay, to generate a 5 second delay. So since 100 milliliter sama dengan 1 second, so you need to make sure that bila mana your water level yang kamu isi dalam botol ni reach, okay, sampai 500 ml, then it will generate 5 second delay. Okay, so this one here, actually you need to set at 500 ml. So you put a threshold here. Okay, your setting. Okay, you set. Okay, so this is my water level. Okay, so 500 ml. So you set a threshold of your water level in order to, okay, at 500 ml. Okay, so what you need to do here is, okay, first this water bottle is empty lah, kosong lah. So apa yang kamu kena buat, you put a water inside here. Okay, so you put water and then this water here will increase. Okay, so increase sampai like it reach 500 millisecond. Okay, when 500 millisecond, what happened? Okay, then you stop. Okay, the delay, the counter will be stopped. So what happened here is now, okay, you already generate 5-second delay. So this is the CTC mode. Okay, another example here is, okay, contoh yang lain. Okay, you have a micropeak speed 1 MHz. So this is your CPU punya clock source lah. Okay, and the content of the counter register increment 1 per microsecond. Okay, so kamu punya counter register is increment every 1 microsecond. Okay, if you're going to generate a time delay of 100 microseconds, so sebab dia kata, okay, 1 tick menghasilkan 1 microsecond. Okay, so now you're going to generate 100 microsecond. So how many ticks you need here? Berapa banyak ticks kamu nak? Okay, so mean that you need to have 100 ticks. Sama lah dengan yang ni. Okay, case botol air kita ni. Okay, so 100 ml sama dengan 1 saat. So you're going to generate 5 seconds. So berapa ratus ml kamu punya air kena sampai, which is 500 ml in order to generate 5 seconds delay. Okay, so this is by using the CTC mode lah. Okay, so this is using CTC mode. Okay, and then next. Okay, so bila mana? Okay, sebelum tu, okay, bila water level ni reach 500 millisecond, so what happen here is, okay, the CPU will give the, okay, akan hantar satu flag. Okay, dia bagi tahu kat, okay, so flag akan set. Okay, one flag will be set. Okay, untuk compare mesh, kita akan pakai OCF flag. Okay, so this flag will be for the CTC mode, flag yang kita gunakan adalah OCF flag. Di mana flag ni, every time water level kamu reach 500 milliliter, so OCF flag akan jadi 1. Bila OCF flag sama dengan 1, so now CPU tahu, okay, so now dah generate 5 second delay. So we need to stop our counter. And then after that, we restart again counter supaya kita boleh buat another 5 second delay. Okay, so this is what happened lah untuk CTC mode. Okay, then we're going to look at the overflow method, which is the second method. Okay, to generate a time delay using the second method. First, what you're going to do here is you need to load the counter register and wait until the counter overflow and the flag is set. Okay, dia punya keyword kat sini sampailah kau punya counter overflow. Okay, yang tadi kita tak ada counter overflow. Okay, which is you need to set lah. Okay, wait until the counter reach a certain number, which is this is the number yang kita set tadi. Okay, until it reach this number, then we stop. Tapi yang ni untuk overflow method need to wait until overflow occurs. So macam mana tu? Okay, konsep yang sama. Kamu ada water bottle. Okay, ada botol air. So this botol air also 100 ml. Okay, so what happen here is, okay, so yang ni, okay, so this is your 1000 ml. Okay, so sekarang benda yang sama. Okay, air yang masuk ke dalam ni, dia punya water flow dia ialah 100 ml sama dengan 1 second. Okay, the flow rate here is 100 milliliter per second. Okay, so now you're going to generate a delay sama dengan 5 second. Okay, tapi sekarang ni kita kena pakai konsep overflow. So how to do that? Okay, to do that, what you're going to do here is, mula-mula apa kita nak kena buat? Okay, kita kena ni lah. Kita kena what we call here set a water level. Okay, dia punya formula dia untuk overflow TCNT, which is this a counter register lah ataupun water bottle, sama dengan maximum. Okay, what is your maximum number? Tolak count. Okay, berapa banyak count level kamu minus 1. Okay, so okay, yang ni nanti kita tengok macam mana dia punya berfungsi. Okay, so this is the formula lah. Okay, tak apa. Nanti formula ni nanti kita akan tengok more details later. Okay, so sekarang ni kamu nak generate 5 second delay. Tapi kamu nak guna konsep overflow di mana apabila air melimpah je daripada ni, okay, if the water is melimpah daripada kamu punya botol ni, barulah kamu generate that delay. Okay, and then you already set the delay. So what you going to do? Okay, 100 mm sama dengan 1 second. So what you going to do here is you need to put here, okay, set kat sini 600 ml. Kenapa 600 ml? Kalau saya, why? Because bila saya set 600 ml, so sini kita dah ada 4 second. Okay, which is daripada 600, 700, 800, 900, 1000 dah kita generate 4 second. Tapi, what happened here? Air tak overflow lagi. So, you need to put, okay, sorry. Okay, contohlah. Tadi kita kata, okay, 5 seconds kan? Kita nak generate 5 second and then dia punya flow rate is 100 ml per second. Okay, by logically, okay, because this is the maximum is 1000 ml. Okay, why not we put at 500 ml? Okay, so kamu set dulu water botol kamu 500 ml. Okay, then you put the water lah. Okay, kamu masukkan air dalam ni and then the water level will increases. Okay, so bila 600 kamu dah generate 1 second, 700 another 1 second, sampailah 1000 ml kamu dah generate 5 second. But if you put 500, what happen? Overflow tu tak berlaku. Kenapa? Sebabnya air kat sini tak melimpah. Okay, which is 100 ml dia dah sama level dengan kamu punya botol. Air tak melimpah. So konsep overflow tak capai. Okay, so that's why we need to put dekat 600. Okay, which is sekarang ni kamu dah generate 4 second. And bila kamu letak je air lagi, and what happen here is air melimpah. So bila air melimpah, konsep overflow dah tercapai. Okay, so this is how the overflow works. Okay, setiap kali what we call here air melimpah, and then that is the delay yang kamu generate. Okay, compare dengan yang ni tadi CTC mode, mula-mula kamu kena letak botol air kamu kosong. Tapi untuk overflow, kamu kena letak dulu air dalam botol air kamu. And then after that, okay, the timers, okay, the delay will be generated after you put a water, okay, inside of this botol until lah dia overflow. Okay, contoh kat sini, a micropeak speed is 1 megahertz. Okay, with an 8-bit counter register, if you want to a time delay of 3 microseconds, okay, what you're going to do is you need to load the counter register with FD and wait until the flag is set after 3 ticks. Okay, sebab kita tahu micropeak speed is 1 MHz. Okay, bila 1 MHz, 1 ticks sama dengan 1 microsecond. Okay, so now you're going to use the concept overflow method. So what you're going to do is, okay, you're going to generate a 3 microsecond. Okay, so 3 microsecond delay. Okay, by right 3 microsecond delay, berapa banyak ticks yang kamu kena ada? 3 ticks. Okay, which is you need to load the counter register with FD. Okay, so what happened here? Okay, for the first tick, content increment jadi FE. Second tick, content increment jadi FF. And third tick, content is overflow, which is dia akan jadi kosong semula. Okay, sebab FEFF ni, kenapa FEFF? Sebabnya kita punya counter register adalah 8 bit. Okay, your counter register ataupun kita panggil dia sebagai TCNT lah. Okay, the TCNT is actually your counter register. The size of this counter register is 8 bit. Kalau 8 bit, maximum number dia adalah FF. Okay, so overflow occur bila FF ni bertukar kepada 0, 0. Sama juga konsepnya ni. Okay, kamu nak generate 5 second delay. Okay, kamu tahu flow rate is 100 milli per second. So what you going to do, you need to have a 500 milliliter. Tapi kalau kamu set dekat 500 ml kat sini, what happen? Overflow tak occurs. So what happen? What you need to do is you need to set water dah dekat 600 ml, and then after that, bila the overflow occurs, then you already generate 5 second delay. Okay, so this is where the formula datanglah, which is TCNT sama dengan FF tolak count tambah 1. Okay, FF yang ni, TCNT. Okay, berapa banyak count is the number of ticks tambah 1. Okay, so FF tolak dengan count kamu 3 tambah 1, so kamu akan dapat FD. Sama juga konsep dengan ni. Okay, kamu punya maximum number is 100 millisecond. 1000 ml. Okay, so kita nak cari kita punya TCNT. Okay, so this is the TCNT lah. Okay, TCNT sama dengan 1000 ml. Berapa banyak count untuk generate 5 second? 500 ml tambah dengan 1. Okay, so that's why kamu akan dapat ni 1000 ml tolak 500 ml, kamu akan dapat 500 ml tambah dengan 100 ml, so you need to set at 100 ml. Okay, so 1000 ml ni actually is equal to 10 lah, yang ni sama dengan 5 dalam konsep ni, dalam konsep TCNT ni. Okay, so that's why kita put dekat 600 ml kat sini. Okay, so this is the introduction. Okay, untuk timer to generate a delay, we have two methods. Satu by using a CTC mode, satu lagi using overflow. Okay, so dia punya kaedah dia, method yang digunakan adalah berbeza if you use a CTC ataupun if you use the overflow. So that is the concept lah, the concept of timer to generate a delay. Okay, so now any question up until here? Ada soalan tak? If no soalan, kita akan masuk kepada macam mana nak buat programming untuk timer 0, timer 1 dan timer 2. Okay, so let's look at the introduction dulu sebelum kita masuk more details on the programming side. Let's look at the introduction of. Okay, so every timer, okay, need a clock pulse to tick. Okay, so setiap timer, okay, dia punya important thing here is clock pulse. Okay, so this clock pulse is very important lah in order for the timer to increment the counter register. Okay, so clock pulse ni paling important. Okay, the clock source can be internal or external. Okay, so this clock pulse can be from internal ataupun external. For the internal clock source, okay, ianya datang daripada frequency of the oscillator. Okay, your external oscillator ataupun kamu punya CPU speed. So that's why we call it as a internal clock source. While for the external clock source here is the feed pulse through one of the AVR pin as a counter. So external clock source ni selalunya kita guna switches lah. And kalau pakai switch, make it as an external clock source. So what you're going to do here is you're going to make a counter. Okay, bukan delay to generate a delay, tapi kamu nak to count and event. So kita ada dua clock pulse, satu internal and satu external. Okay, this is where you're going to put your clock pulse lah. This is your clock pulse. Yang ni. This part is your clock pulse. Okay, sama ada kamu nak internal ataupun external clock source. Okay, so and then you fed it to your counter registers. Okay, and then in Amiga 32, there are 3 timers. Okay, kamu ada 3 timers, timer 0, timer 1, and timer 2. Okay, so kamu tengok kat sini, timer 0 and timer 2, dia punya size adalah 8 bit, while timer 1 size dia 16 bit. Okay, so what this bit about? Okay, so this 8 bit, 16 bit, 8 bit ni is your size of your counter register lah. Okay, if the size is 8 bit, so kamu boleh count daripada 0 hingga FF. Okay, so this is a 8 bit counter register. If 16 bit, maksudnya kamu boleh count daripada 0 sampai FF. Okay, so yang ni daripada 0 sampai 255, yang ni 0 sampai 65,365 kalau tak silap saya. Okay, FF. This is for the 60 bit lah. Okay, and then this timer can be used as, okay, so this timer boleh dijadikan sebagai to generate a delay. Okay, one function of the timer is to generate a delay and to count an event happening outside the micropit. So this is the overview of the counters, and then after that we're going to see at the basic register of timer. So before you proceed with the programming, you need to know kita kena tahulah dia punya basic register. Register apa yang kita kena guna in order to do some programming for the timers. Okay, so dalam Amiga 32, so a total of 4 basic register that are associated with timer. Kita ada 4 basic register yang digunakan dalam timer programming. Okay, salah satunya ialah TCNT. Okay, TCNT N. Small n ni maksudnya dia melambangkan variable lah. Okay, sama ada time kamu guna timer 0, timer 1 ataupun timer 2. So kamu boleh gantikan dekat n ni. Okay, so TCNT is a timer counter register. So this is your counter register is actually. And then you have the TCCRN. Okay, so this is the second one. The TCCR used for the timer counter control register. Okay, so this is untuk timer settings. Kat sinilah kamu nak pilih mode apa yang kamu nak guna. Sama ada nak guna overflow ke ataupun nak guna CTC mode ataupun compare mesh. And then we have the OCRN. Okay, kalau kamu guna compare mesh, kamu kena ada satu lagi register which is dipanggil sebagai OCR, output compare register. Okay, yang ni yang kita nak compare tu, sama ada kita punya TCNT counter register dah sama dengan threshold yang kita setkan atau tak. Kalau tak sama, okay, the counter register will be keep incremented. Okay, and then last but not least is TIFR. Okay, so TIFR ni is your flag register lah, di mana TIFR ni paling important. Okay, every time the overflow occurs ataupun the CTC sampai, okay, which is the level here is sama, so flag akan set. Sama juga ni, bila I melempah je, okay, your flag which is TOV flag. Okay, untuk overflow kita pakai TOV ya. TOV flag akan jadi 1. Selagi I tak melempah, TOV flag sama dengan 0. Sama dengan yang ni. Kalau compare mesh, kita akan tengok pada OCF. Kalau OCF sama dengan 0, maksudnya dia punya level ni, threshold ni tak sampai, water level tak sampai dengan threshold yang kita dah set tadi. Bila OCF sama dengan 1, maksudnya kat situ water level dah sama dengan threshold yang kita setkan. Okay, so dalam TIFR, okay, ada 2 pula flags yang kamu kena tengok. Sama ada TOV flag ataupun OCF flag. Okay, so TOV ni untuk overflow lah. Kalau kamu pakai compare mesh, okay, you use a TOV flag. Kalau kamu pakai, overflow, kamu tengok kat TOV flag. Okay, kalau kamu pakai compare mesh method, then you need to look at the OCF flags. Okay, so this is the timer. Okay, kamu ada 3 timer tadi, timer 0, timer 1, timer 2. Okay, setiap timer ni ada 4 basic register ni. Okay, ada TCNT, ada TCCR untuk setting, OCR kalau nak buat compare mesh, dan ada TIFR. Okay, kamu pun tengok ya. Kalau pakai overflow, okay, 3 ni je kamu kena tahu. Yang ni dengan yang ni. Okay, which is TCNT, TCCR dengan TOVO. Kalau overflow occurs, TOVO akan set, akan jadi satu. Kalau kamu guna compare mesh, okay, so ada 4 register yang kamu kena tengok lah. 1, 2, 3 dan 4. Okay, this is your setting. Yang ni TCNT, yang ni OCR, which is your threshold level. Kamu tengok ni, kalau TCNT sama dengan threshold level, apa yang berlaku? Flag OCF akan jadi 1. Okay, timer 1 pun sama, kamu ada TCNT. Okay, kamu tengok yang ni TCNT 1, yang ni tadi TCNT kosong, menunjukkan this for the timer 0 and this for the timer 1. You have a TCCR untuk settings, OCR, okay, dia ada 1A dan 1B, and ada TIFR flags untuk OCF and OCF 1B. Timer 2 pun sama juga lah, which is you have the TCNT, ada TCCR, ada OCR dengan TIFR. So setiap 4 timer ni ada 4 registers. Okay, you need to have these 4 registers. Okay, so let's look at more detail on what this register do. Okay, untuk TCNT, okay, so it's actually your counter register. Okay, your TCNT adalah kamu punya counter register. So upon reset, setiap kali kamu turn on your microcontroller, value TCNT adalah kosong. Okay, every time you reset or every time you turn on your microcontroller, the value inside of your TCNT akan jadi kosong. Okay, so value dalam counter register akan count up, akan increment which each pass. Okay, akan increment setiap kali dia jumpa clock source. Okay, so this is your clock input. Okay, every time the clock is rising edge atau rising edge, and then the value, the content dalam counter register ni akan increment by 1. Okay, so this content of timer counters can be accessed by loading a value to TCNT or read it value. Okay, so content dalam ni TCNT kita boleh lihat sama ada kita nak baca ataupun kita nak tulis. Okay, later we will see how to write and to read from this register. And then we have the TCCR. Okay, this is the second register lah yang kamu kena tahu. TCCR and register is used for setting mode operation. Macam saya kata, TCCR ni untuk buat setting. Okay, dia ada 2 setting kamu boleh buat sini. Satu is a timer mode. Okay, mode apa yang kamu nak guna? Sama ada kamu nak guna overflow ataupun CTC. And satu lagi ialah prescale. Okay, later we will see what the prescale do. Okay, and then we have the TIFR. Okay, so this is inside TIFR lah. Okay, di mana TIFR ada 2 flag yang kamu kena tahu. One is a TOVN flag and satu lagi is OCRN flag. So TOVN flag akan jadi satu bila mana timer overflow. Okay, every time the overflow occurs, TOV flag akan equal to 1. Manakala OCRN is used, okay, sorry. Okay, TOV dengan ni, OCFN. Okay, so this is inside the TIFR. Okay, and then we have another register called OCRN register. So OCRN register is used to compare the content of OCRN with the content of TCNT. So this is where you're going to do the comparison lah, which is by using the compare match or CTC mode. Okay, we're going to compare value dalam TCNT dengan value threshold yang kita dah set. Kalau OCRN sama dengan TCNT, so apa yang berlaku, OCR flag akan jadi 1. If OCR tak sama dengan TCNT, OCF akan remain 0. Okay, so this timer register are located in the I/O memory. Those we can read or write using in and out instruction. Okay, recall back, data memory ada 3 bahagian. Okay, kamu ada GPR, I/O dengan RAM. Okay, so benda-benda ni semua ada dalam ni I/O memory. Okay, your TICR pula, your TIFR, TCCR0, TCNT0, TCCR1, TCNT1 semua ada dalam I/O register. So that's why every time you turn off ataupun reset, value kat sini akan jadi kosong. Okay, because it is a volatile memory. Okay, so that is the overview lah about the register yang kamu kena tahu sebelum kamu proceed with timer programming. So any question up until here? Ada soalan tak? Okay, so kalau tak ada soalan, okay, let's look at okay, sorry ya, saya tersilap bagi attendance. Sekejap. So, di mana attendance sebenar? Patutlah kamu tak boleh select ya. Sekejap ya, saya bagi semula attendance. So, for the timer 0 programming, so mula-mula kita tengok dulu register-register yang kita nak guna. Tadi kita, okay, saya kata kita ada 4 register, which is TCNT, TCCR, TIFR dengan OCR. Okay, so first kita looking at the TCNT. Okay, since this is a timer 0, so kita akan gunakan TCNT 0. Okay, we have a TCNT 0. Okay, and then macam yang kita tahu, timer 0 adalah 8 bit. So, the size of your TCNT 0 also 8 bit. Okay, so this is your TCNT 0 and you have a 8-bit size. Okay, so since this is a 8-bit, okay, the maximum number that you can count is from 0 until FF ataupun 0 sampai 255. Okay, so that is the maximum yang kamu boleh count untuk kamu punya counter register. Okay, so this TCNT 0 is used as a counter for timer 0. And then next, we're looking at the TCCR0 register, which is the second, what we call it, the second register that you need to know for timer 0, which is the TCCR0. So this TCCR0 also a 8-bit register. Okay, it is used for control of the timer 0. Okay, this is where you're going to do some setting lah untuk kau punya timer 0. Okay, there are 2 locations. Okay, ada 2 tempat yang kamu kena, 2 setting yang kamu kena aware untuk TCCR, dalam TCCR ni. Okay, the first one here dekat ni, bit 6 dengan bit 3. Okay, so bit 6 and bit 3. Okay, what's this bit do? Okay, untuk bit 6 and bit 3, okay, so this one, yeah, okay, we're going to look at this part. Okay, so this is where you're going to select the mode of your timer. Sama ada kamu nak pakai normal mode, which is overflow method, ataupun CTC, clear timer on compare mesh. Okay, CTC is a compare mesh. Okay, kat sini kita nak setting. Okay, so this is your TCCR0. Okay, dia ada 8 bit. Bit yang kita nak kena lihat adalah okay, so first bit here is bit 6 and dengan bit 3. Okay, which is this bit 6 and bit 3 is used for the timer mode setting. Okay, kalau kamu letak 00 dekat bit ni, maksudnya kamu nak pakai normal mode ataupun overflow method. Okay, if you choose put 01, okay, sini 0, sini 1 means that you are going to use the CTC mode. Okay, so this is the first setting yang kamu kena tahu. Mode mana yang nak pakai, sama ada normal ataupun CTC. Okay, then next yang ni 3 bit terakhir, this bit. Okay, so this last 3 bit, okay, which is bit 0, bit 1 and bit 2. Okay, so this bit is used to select your prescale. Okay, yang ni. Okay, so this is the things that you need to know. Okay, kalau 3 bit terakhir tu kamu letak 000, okay, maksudnya you stop timer. 001, no prescale. Okay, later we will see what is the prescale. Okay, 010, okay, prescale divided by 8. Okay, so now if you use a 010, so you're going to use a prescale. 001 tak ada prescale. 011, another prescale. Now you divided by 64. 100, this is another prescaler option, which is you divided your clock by 256, and 101, another prescale option. Okay, divide your clock by 1024. Okay, and then last but not least, 110 and 111. Okay, 110, 1111. Okay, so yang ni kalau kamu nak buat counter. Okay, to count an event, so you need to use this setting here, 110 ataupun 111. Okay, untuk 110, you see external clock source on T0 pin, clock on falling edge. Maksudnya kamu sambungkan kamu punya switch dekat T0 pin, and counter register your TCNT will incremented on the falling edge. 111 TCNT increase on the rising edge. Okay, so this is for delay lah. Yang ni warna hijau ni untuk delay. Warna merah ni untuk counter. So this is the things lah that you need to know dalam TCCR register. Okay, so this is the summaries. Okay, and let's look at these examples. Okay, so you're going to find the value for the TCCR0 if we want to program timer 0, normal mode, no prescaler. Okay, so dia kata kat situ, apakah value yang kamu nak program kalau kamu nak guna timer 0. Okay, kalau timer 0 kita kena setting dekat TCCR0 lah. Okay, so TCCR0, timer 0 dalam normal mode. Okay, this is the important thing. Normal mode, no prescale. Okay, so normal mode kita nak tengok dekat mana. Okay, where we going to set, look at the timer mode. Okay, dekat bit 3 and bit 6. Okay, for normal mode, what value you need to put here? 00 lah. Okay, according to this table here. Untuk normal mode, okay, you need to put 0, 0. 0 at bit 6 and another 0 dekat bit 3. Okay, so that's why I put 0, 0. And then no prescale. Okay, so no prescale, what is the value for the no prescale? Yang ni lah, 001. No prescaling. Okay, so dekat mana nak letak? 3 bit terakhir. So this is the setting. Okay, what about the rest? Yang lain kamu letak kosong lah. Okay, macam mana nak buat programming? TCCR0 sama dengan 0B00000001. Okay, so, kat sini kamu boleh tengok. Okay, ni dengan ni, maksudnya normal mode. This bit here 001. Okay, you use a no prescale option. Okay, next. Example 9.2. Okay, find the timer clock frequency and 8 periods on various AVR-based systems with the following crystal frequency. Assume that no prescale option is used. Okay, so sekarang ni, okay, sebelum kita buat yang ni, okay, there are 3 formula that you need to remember. Okay, ada 3 formula yang kamu kena ingat. Okay, which is T sama dengan 1/F, di mana T adalah period, F is your frequency, and then this is number 1. Number 2, delay equal to T period multiply with count. Okay, count ni adalah the number of the ticks for your counter register, and then last kali nombor 3, TCNT. Okay, your register value sama dengan FF. Kenapa FF? Untuk TCNT 0. Okay, dia punya size adalah 8 bit. Tolak dengan count tambah dengan 1. So this is the 3 formula that you need to remember. Okay, T sama dengan 1/F. Delay equal to T multiplied by count. TCNT 0 sama dengan FF minus count plus 1. Okay, so let's look at this example 9.2. Okay, you're going to find out what are the periods. Okay, given a frequency, diberi frekuensi, cari period, and no prescale is used. Okay, tanpa menggunakan prescale. Okay, so what you're going to do is, dia dah bagi dah frekuensi 10 MHz. Okay, so just use formula nombor 1. T sama dengan 1/F. Okay, since tak ada prescale digunakan, so F is sama dengan original punya F lah. Kalau dia pakai prescaler, so the F, you need to find the new F based on the prescale yang kamu guna. Okay, kalau dia kata prescale 8, so F kena bahagi dengan 8 dahulu, dapat new F, baru kamu masuk dalam persamaan 1. Okay, for example ya. Okay, A 10 MHz, cari dia punya period. Okay, so F sama dengan 10 MHz. So T equal to 1/F is 1 bahagi 10 MHz sama dengan 0.1 microseconds. So means that every 0.1 microsecond, kamu punya counter register akan increase. Okay, so this is the increment lah. Okay, setiap 0.1 microsecond, this is the punya clock punya pulse. Okay, so every 0.1 microsecond, your counter register will increase. Okay, F. Okay, next, diberi frekuensi 8 MHz. So F equal to 8 MHz and T sama dengan 1/F, which 1/8 MHz. So you get 0.125 microseconds. And last but not least, C. If frekuensi 1 MHz. So what are you going to do? F sama dengan 1 MHz and find out what is T. T is 1/F. So 1 bahagi 1 MHz, we will get 1 microsecond. Okay, means that this is your clock input. Okay. So this clock input here, okay, so this is the period T. Okay, so your counter TCNT will increment every 1 microsecond. So this is 1, 2, 3. So every 1 microsecond dia akan increase. okay, of your TCNT. Right, next. Okay, that is for this part lah. Okay, then we go to the TIFR registers. Okay, so what is TIFR register do? Okay, the TIFR is actually kita dah tengok dahulu dalam kita punya timer interrupt programming, di mana TIFR register okay indicates the status of your flags. Okay, timer flags register. Okay, so kamu ada ni, kalau kamu tengok ni, untuk timer kamu ada dua register yang terlibat. Satu is untuk overflow method dan satu lagi untuk compare mesh. Okay, so this one, mula-mula kita tengok nombor kat belakang ni dulu. Okay, so 00, so this is belong to timer 0. Okay, 22, so this is belong to timer 2. So this is the flag untuk timer 2 and this is flag untuk timer 0. Manakala timer 1, this is the flag untuk timer 1. Okay, so we already identified flags untuk timer 0, 1 dan 2. And then now we're going to look kita kena tengok, okay. Since this one here you have TOV OCF. So TOV means that you use the overflow method. So once the overflow occurs, TOV akan jadi 1. Okay, and then you will have the OCF. So OCF maksudnya this one here, the flag untuk CTC mode. Okay, maksudnya if there's OCR and register sama dengan TCNT, so OCF akan jadi 1. Okay, benda yang sama. TOV untuk overflow, OCF, and OCF untuk compare mesh. Okay, so this is untuk flags status. Okay, so since now we use a timer 0, so TOV0 is timer 0 overflow. The flag is set when the counter overflow. So bila overflow je, TOV0 akan jadi 1. Okay, so whenever the time rolls over from FF to 0, TOV flag is set to 1 and it remains set until the software clears it. Okay, and then this is a normal mode. Okay, tadi saya dah tunjukkan kita untuk timer kita ada dua mode. Satu is a normal mode atau overflow mode, and satu lagi CTC mode ataupun compare mesh. Okay, so in the normal mode, the content of the timer or counter increments with each clock. Okay, it will count up until it's reached the maximum, which is FF, and then it will roll over from FF to 00, and once it's rolled over, overflow occurs. And what happened here, TOV flow akan jadi 1. Okay, so this is your TCNT 0 and this is your time. Okay, so the TCNT 0 will incremented for each time kat sini. Okay, setiap kali the time increase, so also TCNT also increase, and the maximum is FF. Okay, so bila mana FF roll over ke 0, so what happened kat sini, overflow occurs, and when overflow occurs, TOV0 akan jadi 1. Okay, so this is for the normal mode. Okay, now we're going to look at the step to program timer 0 in normal mode. Okay, we're going to do the timer 0 programming. Okay, so untuk timer 0 programming kita ada dua tadi, normal mode, CTC mode. Sekarang ni kita tengok pada normal mode dahulu. Okay, so I just create another page. Okay. Okay, so normal mode. What are the steps? Okay, first step. First yang kamu kena buat is load TCNT. Okay, this is the first thing that you're going to do. Okay, you need to load the value of your counter register. How to load a value of your counter register? Based on the calculation. Kita ada 3 calculation tadi. Okay, kita ada 3 equation. Okay, equation 1, T sama dengan 1/F. Okay, I just put down here lah. Okay, so this is alright. So nombor 1, T sama dengan 1/f. Okay. Nombor 2, okay, delay sama dengan count darab dengan T ataupun T multiply with count. And nombor 3, TCNT. So this is where you're going to get the TCNT sama dengan FF minus count plus 1. So this is the 3 formula that you need to remember. Okay. And need to use, okay, setiap kali kamu nak dapat value TCNT. Okay, that is the first step. Load your TCNT. Nombor 2, okay, set your TCCR. Okay, set TCCR ni ada 2 setting. Okay, satu ialah mode yang kamu nak guna. Sama ada kamu nak guna normal mode ataupun normal mode ataupun CTC mode. And satu lagi dekat prescale. Okay, so let's look back at the TCCR. Ini kamu punya TCCR. Okay, dia punya mode setting bit ni dengan bit yang ini. Okay, bit 6 dengan bit 3. Okay, untuk normal mode kamu kena letak 0, 0. Okay, and then the last 3 bit yang ni. Okay, yang ni. Okay, so this is your prescaler option. Okay, so this is your prescale. Okay, dia ada daripada 00, 001, 010 sampailah 111. Okay, that is the second step. Okay, what is the third step? Okay, the third step, okay, then you need to monitor TOV. Okay, so kalau TOV sama dengan 0, maksudnya you need to keep monitor. Okay, until, okay, you need to keep the counting lah. The TCNT will keep increasing until TOV sama dengan 1 dan apa yang berlaku, kamu exit from the loop. Okay, so this is step number kita. We need to monitor the TOV. And then step number 4. Okay, what is the step number 4? Okay, after you TOV satu, macam timer dekat sini tadi, dekat skill ni tadi, satu function di mana kita boleh stop timer. Okay, stop the timer. How to stop a timer when you put a 000 kat belakang ni. So what happen? Stop timer. So in this case here, okay, you need to put TCCR0 sama dengan 0 at 0, 0. So this is how you're going to stop the timer. So this is the coding lah untuk stop timer. And step nombor 5. Okay, what is step nombor 5? Okay, you clear TOV. Okay, kita kena clear balik kita punya TOV sebab tadi TOV sama dengan 1. So now you're going to clear your TOV supaya TOV jadi 0. And 6, repeat step nombor 1. Okay, kalau kamu nak keep doing the timer, okay, keep repeating the delays to generate a delay, so you need to repeat at step number 1. So this is the what we call here the things that you need to do lah in order to create a delay by using normal mode option. Okay, so this is the step lah in order to program timer 0 in normal mode. Okay, so now let's look at the apa ni kita panggil dia sebagai examples. Okay, so macam yang saya katakan tadi, no. Okay, so this is the thing. Okay, we need to do to program for the normal mode. Okay, so let's look at these examples here. Okay, in the following program, okay, we are creating a square wave of 50% duty cycle. Okay, with equal portion and height. Okay, apa maksud 50%? Okay, duty cycle maksudnya sekarang ni kamu nak generate a square wave. Okay, so this is the square wave. Okay, 50% duty cycle maksudnya, okay, since this square wave is consists of logic 1 and logic 0 and logic 1. So maksudnya kat sini logic 0 is 50% and logic 1 is another 50%. Okay, so it have a same length of logic kosong dengan logic 1. Okay, so this is one clock cycle lah. Okay, yang ni satu cycle. Okay, and then it says that on the port B pin number 5. Okay, so you have a ATmega 32. So this is your ATmega 32. This is your PB5. Dekat PB5 ni, you're going to generate a square wave. Okay. Timer 0 is used to generate the time delay. Okay, then you need to analyze the program. Okay, so this is the square wave that you're going to generate. Dekat mana PB5. Okay, and given this what we call program, okay, you're going to analyze. Okay, so first let's look at the headings. Okay, the first line here. So this is the heading. Include avr/io.h. This is yang biasa lah. Okay, so this is the heading. Void to delay. Maksudnya sekarang ni kamu initialize the subroutine T0 delay. Okay, sebab kat bawah ni kita ada subroutine name T0 delay. So we need to initialize dekat sini. Okay, and then follow by your main program. Okay, so this is your main program. Okay, yang main program ni kita dah selalu sangat buat in the previous class. Okay, so tak apa, kita tengok dulu yang first part ni kita tengok dulu, and then later I will just skip on the main program and I'm going to focus on the, okay, kita hanya fokus dekat delay punya programming. Okay, timer programming. Okay, so since sekarang ni PB5 and PB5 ni adalah kamu punya output. Kenapa output? Sebab you going to generate a square wave. Kamu nak generate a square wave, so you need to make sure that the PB5 is your output. So that's why we put DDRB sama dengan satu shift to the left 5 times. Maksudnya yang ni equivalent to DDRB sama dengan 0B 0 0 1 0 0 0 0 0. Okay, dekat bit 5 kamu jadikan dia sebagai output, bit lain kamu jadikan dia sebagai input. So this is what happen lah kalau kamu pakai this data shifting. And then port B sama dengan kosong. Maksudnya sekarang ni kamu hantar dahulu bilang logic kosong dekat port B. Okay, so you initialize your port B supaya port B sama dengan kosong, and this is your while loop. Okay, so while loop, while one, so means that this will do it endlessly. Okay, which is do it forever. Okay, port B sama dengan port B. Okay, exclusive of shift 1 to the left 5. Okay, shift 1 5 times to the left. Okay, so means that you're going to toggle PB5. Okay, yang ni pun saya dah selalu cakap sebelum ni. Kalau kamu nak buat toggling, this is the coding untuk buat toggling. Okay, so maksud toggling ni macam dia. mula-mula kosong, and then bit 1, and then kembali kepada 0, 1, 0, 1, 0. So this you're going to do the toggling. Okay, so toggle ni selalunya kita buat untuk buat square wave. Okay, and then once I do the toggle, so next what happen is to delay. Okay, so sekarang dia akan masuk kepada subroutine. So this is the subroutine number T0 delay. Okay, first TCMT0 sama dengan OXF2. Okay, so this is your first, nampak ni, first step. Load the TCMT. Okay, kamu load TCMT kosong dengan value F2. Okay, and then this is the second step. TCCR0 sama dengan OX01. Di mana set the TCCR. Okay, kat sini kita boleh check apakah setting dia. Okay, since the TCCR value is 01, so this is your TCCR 0 sama dengan OX01. Maksudnya, okay, so this is your bit. Okay, so 0, 0, 0, 0 untuk 0 and 0, 0, 0, 1 untuk 1. Okay, so kita now we're going to look at this bit lah. Bit yang ni. Okay, sorry. Okay, bit 6 and bit 3. Okay, since this is a 0, 0, so you know that this is a normal mode. Okay. And yang ni 0, 0, 0, 1, so you know that this one here 0, 0, 0, 1. 0, 0, 0, 1, this is a no prescale. Okay, yang belakang ni. No prescale. So you know that, okay. Okay, kita guna normal mode tanpa prescale. Okay, and then step number 3. Okay, so this is the step number 3. You're going to monitor the TOV. So this is how you're going to monitor the TOV. While TIFR and dengan OX01. Since this is a normal mode, untuk normal mode, you need to monitor TOV 0. Okay, so mana TOV 0? Okay, what is the location of TOV 0? Dalam TIFR, so you go back your TIFR. And okay, so this is the TOV 0. Okay, dekat value, dekat bit 0. So that's why you need to monitor, the value that you need to monitor kat sini adalah 0, 0, 0, 0, 0, 0, 0, 1. Okay, nak check adakah TOV 0 ni sama dengan 0 ataupun sama dengan 1. So that is what happened here. Okay, is it TIFR and kan dengan OX01 sama dengan 0? If not, okay, it will keep repeating lah. Okay, sebabnya kalau TIFR, so contohlah your current TIFR sekarang ni 0, 0, 0, 0, 0, 0, 0, 0. Okay, so this bit remain 0, and then you end kan dengan 0, 0, 0, 0, 0, 0, 0, 1. So this value here, so what happened? Okay, semuanya akan dapat 0. Since this value is 0, so you will keep repeating lah until, okay, bila mana TOV 0 kamu sama dengan 1. So 1 and dengan 1 kamu dah dapat 1. So sekarang ni dah false. Okay, kat sini dah false. So what happened when false? Step nombor 4. Okay, bila TOV sama 1, dia akan exit from this monitor loop. Okay, and then you're going to stop your timer. Macam mana nak stop timer? Okay, just put TCCR0 sama dengan 0. This is how you're going to stop the timer. And last but not least, okay, we're going to clear TOV. Okay, macam mana nak clear TOV? Okay, so this is how you're going to clear the TOV lah. Okay, this is a special case. Untuk clearkan kita punya flag, we need to put 1 to our flag location. Okay, since sekarang ni kita nak clearkan TOV dekat sini. This is your TOV. Okay, you're going to clear this TOV. So what you're going to do is, you need to make sure that TIFR sama dengan 0, 0, 0, 0, 0, 0, 0, 1. Okay, so this is how you're going to clear your TOV. TOV 0. Okay, so yang ni dia punya penerangan lah. Okay, so what happened here? So mula-mula you load TCNT0 sama dengan F2, so this is F2, and then after you set the TCCR 0 and the timer 0 akan started lah. So what happen here is, okay, so F2 TOB masih lagi kosong. When F2 naik ke F3, TOB 0 masih lagi kosong, and then pergi ke F4, TOB 0 sama kosong until FF. Okay, when FF, TOB 0 masih lagi kosong. Okay, when FF roll over to kosong, now what happen? TOB 0 sama dengan 1. Bila TOB 0 sama dengan 1, okay, this is what happen lah. This is when the monitoring process, okay, step number 3. Okay, bila TOB kosong sama dengan 1, so what happen? It will exit from this monitor punya loop and kamu stop timer. Okay, so timer 0 is stop. Okay, macam mana kamu tahu nak stop timer? TCCR 0 sama dengan kosong. So this is the code that you're going to use in order to stop the timer. And then after that, we need to clear the TOB 0 flags. Okay. Okay, next. Okay, so this is how to analyze lah. Okay, so next we are going to what we call here. We are going to look at this example and write a programming to generate this delay here. Okay, so in example 9.3, okay, calculate the amount of time delay generated by the timer. Assume that the X-tel sama dengan 8 MHz. Okay, so dia suruh kita dapatkan berapa kita punya delay. Okay, so macam mana nak calculate dia punya delay? Okay, by using this formula yang ni. Ada 3 formula tadi, kita nak pakai 3 formula ni. Okay, so formula 1, T sama dengan 1 over F, delay sama dengan count darab T, and TCNT sama dengan FF tolak count tambah T. Dalam example 93 tadi, TCNT, okay, kita load TCNT tadi sama dengan berapa? Kalau kamu tengok kat sini, step nombor 1, TCNT sama OXF2. Okay, so OXF2. Okay, so this is the TCNT. Sama dengan OXF2. Okay, so from this persamaan 3, you can find out what is your count. Okay, so since OX, okay, so F2 sama dengan FF minus count plus 1. So count kamu akan dapat FF tolak F2 tambah 1. Okay, just press the calculator. Hexa FF tolak F2 tambah 1. So kamu okay, and then you okay, so yang ni kamu akan dapat 0E, tukarkan dia, kamu akan dapat dia dalam 14. Okay, so sorry. Okay, so hexa tukar dalam desimal, kamu akan dapat 14. So you already get the count, and then delay sama dengan count darab T. Okay, so sekarang ni kamu nak find the delay. Okay, kamu dah ada count. Okay, so sekarang kamu kena cari T. Macam mana nak cari T? Daripada X-tel. X-tel dah diberi. So by using the first formula, you can get the T. T sama dengan 1 over F sama dengan 1 bahagi 8 sama dengan 0.125 microsecond. Okay, so yang ni kamu dah dapat, T dah dapat, count pun dah dapat. Now you can calculate the delay. So delay sama dengan T 0.125 microsecond darab dengan count. Okay, what is your count? Count tadi 14. So kau darab je lah dengan 14. Okay, so what happened? You're going to get 1.75 microsecond. So this is the delay. Okay, and then we look back lah dekat sini. Okay, maksudnya kat sini tadi. Okay, so this is your square wave. Okay, so this is 50 cycle ni, maksudnya kat sini kamu generate of 1.75 microsecond untuk logik kosong and another 1.75 microsecond untuk logik 1. Okay. Any question? Okay, so yang ni finding a value to be load into the timer by using this 3 formula ni je lah. Okay, macam mana nak dapatkan value untuk kita letak dalam TCNT. Okay, any question? Ada soalan tak sehingga sini? Okay, if no question, okay, so now we are going to write the C programming. Okay, so let's look at this example here. Okay, given that Xtel sama dengan 8 MHz. Okay, dia bagi tahu kat situ Xtel. Okay, your speed is 8 MHz. Okay, and then write a program to generate a square wave with a period of 1 to 12.5 microsecond on pin port B3. Okay, so lukis dulu. So this is your B3. Okay, and then you're going to generate a delay. A square wave. Okay, and then dia bagi tahu kat situ. Okay. Okay, write a program to generate a square wave with a period. Okay, the period is 12.5. Okay, so the T. Okay. Untuk yang ni, T ni bukan T yang ni tau. T is not the T, this one. Ini another T, T yang lain. Okay, this is the T of your square wave. Yang ni, this is T. 1 cycles. Okay, dia dah bagi sini 12.5 microsecond. This is not T untuk kamu punya delay. Okay, so this is the T untuk square wave. Okay, so this is a 12.5 microsecond. Okay, so what you're going to do here is mula-mula, okay, kamu dah dapat Xtel sama dengan 8 MHz. Okay, so by using the formula nombor 1, T sama dengan 1/F. So kamu dapat 1/8 MHz. Alright, so kamu dapat 1.25 microsecond. Sekejap ya, saya betul tak saya punya calculation ni. Salah. Bukan 1.25 microsecond. 0.125 microsecond. Okay, so 0.125 microsecond. Okay, so sekarang ni, this is your T. Okay, tapi yang ni tadi given T is your T of this square wave. Okay, since this one here, the T is 12.5. So, untuk generate a square wave, kamu ada logic 1 and logic kosong. So what you're going to do here is, this is you need to divide it with 2 and then kamu akan dapat yang ini adalah 6.25 microsecond. Okay, so this is another 6.25 microsecond. Okay, so sekarang, okay, so since this is a formula nombor 1. Formula nombor 2, okay, delay sama dengan count darab T. Okay, tadi kamu dah dapat ni. Okay, T sama dengan T untuk square wave is 12.5 microsecond. Okay, then kamu dapat, okay, so untuk generate logic high and logic low, you need a 6.25 microsecond. So this 6.25 microsecond is actually your delay. Okay, so this is actually your delay. Kan tadi kan kita dah generate yang ni square wave. Okay, so this is actually your delay yang kat sini. Okay, this is your delay. Sama juga dengan ini, delay kita yang kita nak generate is 6.25 microsecond. So what you going to do? Okay, since delay is 6.25, so 6.25 microsecond sama dengan count kita tak tahu lagi. T kamu tahu sebab T is 0.125 microsecond. So kamu akan dapat count equal to, okay, 6.25 divided with 0.125. So kamu akan dapat 50 times ataupun 50. Okay, so 6.25 bahagi dengan 0.125 kamu akan dapat 50 times. Okay, and then sebab kita nak buat timer programming. Okay, the timer programming, the first step yang kamu kena buat is you need to load the TCNT. So how to load the TCNT? Okay, you need to do this formula lah. Okay, so step number 3, TCNT sama dengan FF minus count plus 1. Okay, you need to figure out what is your TCNT. Count kita dah dapat, FF ni kamu gantilah dengan 255. Okay, FF is 255, tolak 50 tambah 1. So you will get 255 minus 50 plus 1, kamu akan dapat 206. And then this 206, okay, kamu tukarkan dia ke dalam hexadecimal, okay, you will get OXCE. So this is the value that you need to load to your TCNT. Okay, and then barulah kita, okay, barulah kita buat kita punya programming. Okay, so saya tak nak ni. Okay, I just skip this part here. Yang ni. Sebab yang ni main program, saya tak nak fokus on the main program. I'm going to focus dekat sini, subroutine delay ni je. Okay, macam mana nak buat. Okay, yang ni kamu ni lah. Untuk main program, mula-mula kamu kena initialize port bin ni supaya dia jadi input output port. And then after that, under while loop, kamu kena buat toggling punya proses and panggil delay. Okay, yang ni benda semuanya lebih kurang sama je. Okay, depending on the program lah yang kamu nak buat. Okay, I'm going to focus on this part here untuk timer punya programming. Okay, for the timer programming, okay, the first step what you going to do? Okay, mula-mula kita buat kita punya what we call here. Okay, timer punya subroutine. Okay. So yang ni kamu boleh letak apa-apa nama je lah. Okay, void to delay. Okay, timer 0 delay. Okay, what is the first step? Nombor 1, you're going to load the TCNT value. Okay, since we already find out, okay, kita dah dapat dah kita punya TCNT. So just tulislah TCNT kosong sama dengan OXCE. Okay, so this is the first step. Second step, set your TCCR. Okay, so sekarang kita nak letak value apa dalam kita punya TCCR. Okay, since in this example here, okay, we are going to use timer 0. Okay, normal mode and no prescale. So, macam mana nak buat setting? Okay, rujuk baliklah kita punya TCCR. Okay, so this is timer 0 normal mode without prescale. Okay, so bit 6 kena letak 00. Bit 6 and bit 3 00. Without prescale kamu kena letak 001. The rest samalah, letak kosong. So this is the value that you need to put. Kosong B sama dengan kosong, 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 1. Okay, and then next, this is the second step. The third step, okay, monitor TOV0. Okay, so you just tulis dia balik semula. Yang ni kamu boleh Y TIFR and with. Okay. Okay, so TIFR and dengan TOV kosong. TOV kosong tadi kedudukan dia kat mana? Dalam TIFR dekat sini. Okay, so this is your TOV kosong dalam TIFR. So you need to end with 0 at kosong 1. Okay, you need to monitor this value here. Okay, kosong 1. Okay, and then adakah dia sama dengan kosong? If yes, keep monitor. If not, what happen? Step nombor 4. Okay, stop timer. Okay, and step nombor 5. What is step nombor 5? Okay, clear your TIFR. Okay, clear your TOV kosong. Macam mana clear TOV kosong? TIFR sama dengan OX 01. Okay, kamu kena letak 1 dekat TOV kosong baru kamu dapat clearkan balik TOV kosong punya flag. So this is the step. Okay, this is the timer programming. Okay, so saya cuma nak highlight kat sini. Yang kamu nak kena tukar ialah yang ni, value TCNT. And then sometimes kamu nak kena tukar value yang ni dengan yang ini dekat TCCR kosong. Untuk step nombor 3, tukar je value yang kat sini. Step nombor 4, salin balik benda yang sama. Step nombor 5, value yang ni kena tukar. Okay, yang ni kena sama dengan yang kat sini. Okay, itu je tempat yang kena tukar. Yang lain, sama. Okay, so this is for timer 0 programming using normal mode without prescale. Okay, any question up until here? Ada soalan tak? Okay, saya rasa macam tak sempat dia nak buat revision untuk test 2 punya ni. Sebab kita banyak lagi ni nak kena cover ni. Okay, timer programming ni akan masuk dalam kamu punya final, definitely. Okay, so you need to focus lah. Okay, how to write the timer programming by using C language. Okay, any question up until here? Ada soalan tak? Okay, if no soalan, I think we stop here dahulu. Okay, and then after that, we continue with what we call here pukul 2 nanti. Sambung balik semula, kita tengok prescaler and then CTC mode. Okay, boleh ya? And then after that, barulah kita continue with our test.
Okay, Doktor. Thank you.
Okay, Doktor.